This is video of our first experiment, which is about the specific gravity and absorption of coarse aggregate. Starting with the purpose of the experiment, then the theory, apparatus needed, experimental procedure, the result, and lastly the discussion and conclusion for this experiment. The purpose of the experiment is to determine the specific gravity and absorption of coarse aggregate. The specific gravity may be expressed as bulk-specific gravity, bulk-specific gravity SSD, or apparent specific gravity. Moving on to the theory of the experiment. The mass of oven dry sample in air will be labeled as A. Then, B will be the mass of the saturated surface dry sample, while C will be the mass of the saturated sample in the water. These are the formulas that will be used to find the result. The apparatus needed for this experiment will be the balance accurate to 0.01 kg, water tank, wire basket, a metal container to fill the aggregates, 75 mm sieve, and tissue for wiping the aggregates till dry. This is our experimental procedures. First, we reduce aggregate sample of different sizes to approximate quantity needed by using aggregate sample stripper. Then, we remove all the materials that pass through the 4.74 mm sieve by dry sieving and thoroughly washing them to remove dust or other coatings from the surface. As the nominal size of aggregates is 12.5 mm, the weight of the specimen should be no less than 2 kg. Next, to get the value of A, we weigh the empty container and then the container with the aggregates. By subtracting the weight of container from the weight of container with the aggregate, we can get the value A. For C, first the aggregate will be immersed in water tank for about 10 minutes. This is to make sure the aggregate is saturated. After that, weigh a person holding empty basket soaked in water, and then the person holding basket with aggregate soaked in the water. By subtracting the two values, we can get C. Wipe the aggregate till then dry with tissues. Return them into the SSD state. Finally, weight basket with the SSD aggregate and then weight the empty basket. By subtracting the two values, we can get the value of B. This is the result for our experiment. You can see the weight of each component on the table. The value of A, B, and C were obtained through these calculations. By using the formulas, we can get the result as shown on the table. The final part of this video is the discussion and conclusion for this experiment. We were not able to wash the aggregate before starting the experiment. There might be some unwanted substances mixed together in the aggregates. There was no oven in the lab to dry up the aggregate perfectly. Therefore, we were not able to obtain the mass of oven dry aggregate in the air as well. To make sure that the aggregate is fully saturated, the aggregate should be immersed in water at room temperature for more than 24 hours. However, due to lack of time, we were unable to wait for such a long time and had just immersed the aggregates for 10 minutes. Therefore, we had no choice but to only weight the aggregate without fully saturated. There was no spring balance in the lab. Therefore, to make sure the buoyancy force was applied on the aggregate, we stepped on the balance at the same time holding the wire basket and immerse it into a water tank fully filled with water. Lastly, there was not enough time for us to dry the surface of aggregate perfectly. Therefore, the mass of saturated surface dry aggregate may be affected. The result shows that the bulk-specific gravity in SSD state is larger than the bulk-specific gravity in absolute dry state. Meanwhile, the apparent specific gravity was the largest. That's all for this video. Thanks for watching.